Let's create a simple utility to back up our folders directly to the cloud. Let's code. Hi, I'm Rafael, and this is Coder Cave. Over the next 30 minutes, we are going to build freezeme, an easy-to-use command-line tool to create backups of our local folders and store them directly into AWS S3 Glacier. First thing, we are going to build the command-line interface using click. Then we will manage a settings file with YAML. After that, we will use zipfile to compress our local folder. Then we will use bot3 to ship this archive to AWS S3 Glacier. As a first thing, I want to create the command line interface for freezeme. I created main.py in the freezeme folder so that it's really clear that this is the entry point. Now, freezeme is going to be our main method that is going to be doing most of the work. I will use click as a tool to create the command line interface. Click is a fairly neat library that makes it very easy to create interfaces. So freezeme is going to be a click group. A click group is basically an aggregate of commands. I want to be able to invoke freezeme without subsequent or subcommands, so I will decorate, or I will specify that I want it to be invocable without commands. Now I also need to define init as a command, so I just decorate that with click command. And now that I have my group and my command, I need to tie them together. So I will do a freeze add command init. So with this, I tied everything together. So I have a very, very basic scaffolding of the interface. Now, the freezeme method is going to use AWS to upload a file. So I need a way to authenticate to AWS. And I will do so by passing a parameter called profile. This is fairly standard when using AWS command line interfaces. So I'm going to replicate this here. The profile is going to be the name of the profile on your local machine where you have the keys that allow you to authenticate to AWS. How to use it in the freezeme method? Very simple. I just pass profile as a command, as a method argument, and I can use it here. So just for test purpose right now, I'm going to print it. Click makes it very simple to define a default and even better, a help text. This is going to help the user understand what those parameters are for. So I don't need to create something that prints a help text. Click is doing that for me. Now I want to add one parameter to the init method as well. Init is going to create a basic configuration for freezeme, and part of this configuration is the region, the AWS region, where I'm going to create the S3 bucket where my files are going to be uploaded. So I pass an option called region. I'm defaulting to EU Central 1, which is Frankfurt. It's the closest AWS location to my physical location, so I'm picking that as a default. And as I did for freezeme, I'm passing region as an argument to my method, and I'm going to output that just for demonstration. Okay, with this basic scaffolding, we should be able to test it, but first I need to resolve this dependency. I created this project using Poetry, and I will use Poetry to add the dependency to click. So Poetry add click. This is going to get the dependency and also define the lock the dependency in the project. So in the project file, I see we are going to use click 712, and the Poetry lock is also defining somewhere which version of Poetry we want to use. Alright, so with this, we should be able to make a very quick test. Alright, so we issued the main command, so this is freezeme, and it's picking the default parameter, but if I say profile, my profile, it's going to pick my profile. Let's say I want to also say, with the same my profile, I will say also init, and the region will be US East 1, which is in Virginia. We see that both commands are executed. I have my profile and US East 1 as a region. Okay, I need some more decoration here. I want to be able to invoke freezeme without init, and I need to test this in my method. So I need to make the main entry point context aware. And with click, I just need to decorate with pass context and add a ctx argument in my method. Now, for good measure, I will decorate also the init method with the context awareness, and I will pass the context. Okay, with this, I will also add my test in the freezeme method. So this is going to make sure that what's included inside the if block is invoked only if freezeme is invoked without a subcommand. So if I say freezeme init, everything in this block is not going to be executed. And this is going to be the case when I want to initialize a folder. Now that we have a basic scaffolding of the command line interface, we are going to work on the settings module. The responsibility of the settings module is to create and load settings for a specific folder. The setting file is going to be a YAML file in format, and I'm going to use pathlib to manipulate the file system. To generate the name of the S3 bucket, I'm going to use UUID4 to make sure I'm generating a unique bucket name. For simplicity, I'm going to store the settings as a dictionary in memory. Now, let's assume that the settings file exists, so the path will exist. So if the settings is not has not been initialized yet, I'm going to test if the path exists. And if it does exist, I will just load the content of the file in the settings dictionary. Okay, so with this we are loading the settings, but we need to make sure that we are manipulating the global settings. Otherwise we risk creating a local variable. Alright, so with this we are loading the settings from the YAML file if it exists. Now, if it does not exist, but the parent path exists, so this means that we have a valid path to work with, then here we need to create a set of default settings. And to do that, I will create a method called getDefaultSettings. I already have a snippet for that. So very simply, this is going to get the parent path, so the place where we want to create the settings file. Here I also define what version of the file we have, and this is going to be a constant in our module. So this is going to be version 1 of the settings file. So the default setting so far contains the file version. I will generate a UUID to create a unique bucket name. The bucket name is composed by FRZM. This is a compaction of freezeme dash. I will use the first 22 characters of the path. This is to comply with the Amazon requirements for the bucket name, and then the UUID just created. I will also replace blank spaces with dashes to make sure the name is valid. In our settings, I will define the bucket name. In the settings dictionary, I would say that the bucket name is the name I just defined over here, and the region is the default region. So for that, I will need to define a few more constants. And in this case, I will also define a default region. And default region again is going to be EU Central 1. With this method here, we have our default settings. So in case back to the load settings. In case we do not have a valid settings file, we create a set of settings. Now, because the load settings accepts the region, we are going to set the region in our newly generated default settings. So we can override the region. And now the last few steps, very simply, we are going to write the YAML file to the file system. So I will convert the dictionary to a YAML string with YAML dump. And then I'm going to use pathlib to write the YAML to the file. And as a last step, I'm going to load or to basically transfer the content of default settings to the global settings object. Now, in the case, the final case here, so this is if we don't have, if the path does not exist and the parent path does not exist, we are going to say that we have an invalid parameter, so we are just returning an exception. And now that the settings module is ready, we can work on the command line interface method that creates the settings file. So first thing, I will need to import the method. And I'm going to use it over here. So settings is going to be load settings. So here I need a few parameters. I first need the path to the settings file. And here I will really sort of hard code it. I will define that the settings is going to be in the current working path, and it's going to be called .freezeme. So for that I need to import pathlib. Okay, so here I will pass settings file as a parameter, and then I will pass the region that has been passed via command line. So this is going to let me override the default region in the settings file. I also need the settings in the main method here, obviously. Okay, so now we can move on with the main method here. So the next thing we need to do is to create the name for the zip archive that is going to contain all the files that we want to back up. So here I define this simple structure. I will be using the name of the current working directory, replace the white spaces with underscores, and then I will use the date time now, so the current time, to determine the name of the archive. So the archive is going to contain the name of the path and the time down to the second when the archive was created. So this is going to make it easy to sort the files, the archives. So here I need to import date time. Okay, so I have now the name of the archive. I will just print this name so that the command line interface receives the name of the archive. I also need a reference to the current path, because I will then use this to start compressing the content of this folder using a module called zipper that I'm going to develop next. Up to this point, we created the command line interface and the settings module. We now need to create a module to compress our folder, and then another module to ship the compressed file over to AWS Glacier. I will start by creating the zipper module. This module is going to walk a path and compress every file present in that path. So let's start with the method that walks the path and retrieves all the files. So all files is going to be a list, and we'll return that at the end. Pathlib makes it very simple to walk the path. I just need to invoke iterdir on the path, and this is going to let me access every single file or directory. So if the file, or if the element returned, the current element is a directory, I'm going to make a recursive call. So all files is going to be extended with the result of walk on that directory. So this is a recursive call. Otherwise, if it's not a directory, it's going to be a file. I would say that all files append x. So we add that file to the list of files. And with this, we walked the path. Once we have a method to get all the files, we can invoke it in the zipfiles method by passing the path, that is the argument for the zipfiles method. Now we need to create a handle to a zipfile object. This is an object that lets us compress files. So we'll pass the archive name. I will open the file with a write mode, and I will define the zip algorithm as zip deflated. So next thing, I will walk, or actually I will grab all the files contained in the all files list, and if the name, if the file name is not .freezeme, I will add that file to the zip archive. Now .freezeme is the default name I will give to the settings file, and I don't want to compress the settings file. So with zip, calling the write method on a zip file object is going to add that to the archive, and then I can call close, and this is going to actually write the archive to the file system. With that done, I'll move on to creating a new module called Glacier. This is going to be the module that lets me interact with Amazon S3. So to interact with S3 or with the Amazon services, I will use Boto3. Boto3 is a library that makes it fairly simple to interact with AWS. I need a method to save an archive in the bucket. So to do that, I first need to create a client that interfaces with AWS. Since I want to pass an authentication profile, I will first create a Boto3 session, passing the AWS parameter as an argument in the save bucket. And then with that, I can move on to create a client. Next step is to obtain the bucket name. The bucket name is part of the settings. So I will extract that from settings, which is also an argument to the save buckets. Now, to get into the settings, I will import those constants from the settings module. All right, I have a client, I have the bucket name. So now I need to make sure that the bucket exists, because if it doesn't exist, I cannot put objects to that bucket. So I'm going to use this trick to verify that it exists. I'm going to call the head bucket on the bucket name that I have in the settings. If the head method throws an exception, I will reasonably know that the bucket does not exist. And to create it, I will create a small private method called createBucket, which is only going to issue a createBucket API call on S3. It will create the bucket with the name I want, it will make it private, and it will create it in the region I decide where I want my bucket. And again, this is a settings parameter, and for this application the default is EU Central 1, which is in Frankfurt. At this point I have a bucket ready, created, so I'm ready to put my archive file. And to do that, I simply call the putObject method of the S3 client. I say, I tell it in which bucket I want this file to go. I need to specify a key. A key is like a path on a file system. I just want that to be the archive name. I don't want to complicate it. I pass the content of the file in bytes, make it private. And over here, I'm going to change this from standard to Glacier so that the cost of storing that file drops by a good 90%. The trade-off is that Glacier archives cannot be retrieved right away. I will have to issue a request to retrieve that file before I can actually use it. To make sure that Boto3 and Botocore are available, we'll need to issue a poetry add Boto3. This way, the reference will be finalized into the project. Alright, so also Botocore was added. Alright, now we have our zipper module to compress the folder and the Glacier module to upload the compressed folder to AWS S3 Glacier. Let's go back to the command line interface and complete the main method. Alright, so here we already have the reference to the current path. We now want to create a zip archive from this path. So I'm going to import those modules. So from freezeme.zipper, I will want to import zip files. So here I can say zip files, and I will pass the path that I just got over here and the archive name. So this is going to create an archive. Then I want to reference the path to that archive. So the archive path is going to be the path / archive name. This is a very concise notation from pathlib that allows me to create a fully functional path with very minimal code. Alright, so the last thing, once I have an archive, I want to save it to the bucket. So I'm going to import the Glacier module, and from this module I want save in bucket. So here, save in bucket, I want to save using my settings, the settings that I loaded at the beginning of the method. I will use the archive path, so I know where the file is, and my AWS profile that has been acquired through the command line interface. Okay, so at this point, we have our file uploaded to S3. What I want to do as a last thing is to delete the file from the local file system. I mean, delete the archive. And this can be done with the unlink call to the path. This is not an intuitive name for this method, but you can keep in mind that this both deletes a file or removes a logical link. Before we can build our project, we'll need to add the reference to the entry point in the project file. So in the section tool poetry scripts, I'm going to reference the main method for the application, which is in the freezeme main module, and the method itself is called freezeme. And I give the name freezeme to the whole application. So this is going to be the way I invoke the command. So with this, we are ready to build poetry build. This is going to create a new folder called dist, and it contains the tarball and the wheel file that I can use to install the application. So to test that the application works, I moved to a different folder that contains some pictures and Photoshop files for the Coder Cave YouTube channel. So let's see if freezeme works. I will use the profile caveman, which is my local profile, to authenticate to AWS. So it's creating an archive here. I'm expecting it to take a while to upload the file. And here we got a response from AWS. And here we can see that the file was successfully uploaded to S3. The bucket was created according to the name found in the init file, in the configuration file. So see D3602, D3602 over here, and we have the archive created over here with the correct naming. So if we issue again the freezeme command, we can expect to have one more archive popping up in that folder or in that S3 bucket. And there we go. And they have the storage class set to Glacier. In this episode, we saw how to use click to create command line interface, zipfile to archive our folder, butto3 to upload to Glacier, and we saw how to use poetry to manage dependencies and build the project. In the next episode, I will refine how the file is uploaded to Glacier in order to make it more fault tolerant, and I will also implement the retrieval functionality. Keep in mind that Glacier is not like standard S3. You cannot just download a file. First, you need to ask for retrieval. Make sure you subscribe to the channel so you don't miss the next episodes. In future episodes, I want also to build a web UI so that we can have more visibility into what is retrieved. All the code for this project is available at github.com/codercave/freezeme.